Okay, alright, hello everyone. So, in this video, what I want to do is chain roll, okay? I will admit, it's a little difficult to explain because, number one, I did not really do it using, I think it's called like Leibniz Notation or something like that, where if you have dy dx equals du dy times, and I think it's like, or actually, hold on, it's dy du times du dx or something like that, and you cancel these out, right? I didn't do it that way when I was in Calculus 1. I did it a different way, okay? The way that I did it was more, it was a little more complicated than that. So I believe in the last video that I did, I went ahead and, at least I believe I did, make a video on how to, basically, when you have a composition of functions, how to decompose them, if that makes sense. Hold on. Yes, like undoing the composition of functions. And I did that to do Leibniz notation in this video. I guess in reality, I will do Leibniz notation in this video, but it's going to be a pretty lengthy one. Only because I'm still kind of new to it and it takes a while. So yeah. I will show how I did it myself, like when I was in Cal 1, and then I'll show it using the Leibniz notation. I'm pretty sure that a lot of you probably will find the Leibniz notation a lot easier than the way that I'm going to do it. But, because I'm sure that it makes more sense. The way that I do it is a lot faster, but I feel like if I do it that way, it won't make much sense. So whoever watches this video, I would like your feedback on whether or not it made sense to you, like the way that I did it, and versus Leibniz notation. So again, what Leibniz notation is, it's basically you have dy dx, and that's going to equal to, I believe it's du dx times dy du. And yeah, basically that's how you do it. Now, for example, let's say I had something like or let's just say we had f of x equals e to the x squared plus 3, right? And I want to find f prime of x. Now, the way that I usually do it is I grab the function, let's say this entire function, I write it down, so it's going to be e to the x squared plus 3, and then I grab this function here on the inside, on the upside here, and I say times the derivative of this of the function on the top, okay, like that. So then I say 2x e to the x squared plus 3, right? Now, using Leibniz notation, the way that they would do it is they would say, well, in reality, we have y equals e to the x squared plus 3, right? And then they would say, well, in reality, where so basically they say u equals x squared plus 3 because they use u substitution, and that's another term, that's kind of a new term for this channel, is u substitution. U substitution just means that you're substituting a variable in for the algebraic expression. So u in this case, basically, the letter u. So we have u equals x squared plus 3, and then let's see. So it'd be f prime of x, and it's gonna be so then that means that if I take the derivative with respect to x of u, that means that du dx. So for example, if I said y equals 3x plus 3, that means that dy dx is just 3. That's how we would say it, right? If I say that y equals x squared plus 3x minus 6, I would say dy dx is equal to 2x plus 3, right? That's how we would say it. Now this is in terms of u. So the derivative of u, the way that we read this is the derivative of u with respect to x. Now, with respect to x, that means with respect to the x-axis, okay? So that's what that means. So du dx, in this case, you would just take the derivative of this function here, the x squared plus 3. So you would say du dx equals 2x. Now, that's this part, right? So we know this part, and we also know what dy dx is, or not dy dx, excuse me, not this part. So now we want to find what, so if we make u equal to x squared plus 3, then that'll be, that'll make, basically, in this part here, we can say u equals x squared plus 3, and that'll make y equal to e raised to the u power, which is right here, which is in green right here. So then we're going to say that dy du, or dy du is going to be equal to e to the u, because remember, the derivative of e to the x is just e to the x, right? So dy du is just e to the u. Now that means that when we substitute u back in, dy du in reality, it's just going to be e to the u, and then substitute u back in. That'll give us e to the x squared plus 3. So dy du will be e to the x squared plus 3. Now we're going to go ahead and finally plug all of these in for to find the derivative. So we know that du dx is 2x, right? And dy du is e to the x squared plus 3. So dy dx is going to be equal to du dx, which is 2x, and then times, and then if I do the purple part here, 2x times e to the x squared plus 3 power. So basically we have, this is in blue, so right here, like this, okay? And that's what that is, right? In reality, that's what that is. So that's how you do it using Leibniz notation. Now the way that I did it this way. I did it this way. I said it's the derivative of the very outside times the derivative of the inside function, which is x squared plus 3. Now let's look at another one, okay? Let's say we had ln of, I'm trying to see, natural log of, or maybe we can do, let's make it a little harder. So let's say sine of the natural log of 2x f of x equals sine of the natural log of 2x. Now, you're going to take, so first, pretend that u is equal to ln of 2x. And pretend that this is y equals sine of the ln of 2x, or natural log of 2x. I know a lot of people say ln, but it's really natural log of 2x. That means that du dx will be, and again, if you want, you can actually grab the function ln of 2x and take the derivative of that using Leibniz notation. If that's what you want, you can say, so let me first go ahead and show you guys how I would do it, okay? And then I'll use Leibniz notation, because I feel like if I use Leibniz notation, I don't want y'all to think that I'm just doing it because, like, I'm just kind of like making my own method up. So basically, the way that I would do it is, I would say this, so f prime of x is going to be, and let's just look at the function sine of something, right? Sine of something, okay? Okay, so we're going to say, what is the derivative of sine of something? Well, that's going to be the cosine of something, right? So whatever that something is, we're going to go ahead and just put it in. ln of 2x, cosine of ln of 2x, times, and then we're going to look at the inside. We have the ln of 2x. Well, that is the ln of something. So I know that, for example, so let me write this down. d du of sine of u is just cosine of u. And then d du of ln of u is just 1 over u. So then I'm going to say that the ln of 2x is just 1 over 2x times the derivative of this inside part here, okay? And then I'm going to say, well, okay, what is the derivative of 2x now? Times the derivative of 2x. That's just going to be 2. So then I'm going to say f prime of x is equal to, so it's 2 over 2x cosine of the ln of 2x, or natural log of 2x. Cancel this out, so then you're going to say that this is equal to, so this is f prime of x is equal to the cosine of the natural log of 2x all over x. Now, let's do this using Leibniz notation, okay? So, again, I'm going to do this, like, step by step, because in reality, so, okay, this is really, so I can make u equal to ln of 2x. Okay, let me just rewrite this. Let me rewrite the problem down so that I don't get you guys confused. I'm going to say f of x equals sine of ln of 2x, okay? And I promise, guys, I'm not going to look back. So, So if we look at this, I say, okay, u, so let's make u equal to ln of 2x, right? And let's turn this into y equals, because that way we can use a dy du form, right? Now, so if I grab, for example, if I grab the, or actually, let's go from the very inner and then go outwards. So let's first look at y equal, let's first look at this part. Y equals ln of 2x, right? And I want to take the derivative of that. I want to say, what is dy dx, right? Dy dx. The derivative with respect to x of ln of 2x, what is that going to be? Well, if I can make u equal to 2x, right? Because that'll give me ln of u, natural log of u. And then, so I can say that y is equal to ln of u. And then, let's see, du. So that means that du dx, the derivative of u, of u with respect to x, is going to be just 2, right? So basically I'm going to have, so I'm going to write down my formula, dy dx is equal to du dy times dy dx. Or dy du, excuse me. Or no, hold on. It's, oh my goodness. It goes like that. Du dx times dy du. Now, if we look at this, so we know that du dx is 2, right? Now, what is dy du? If I look at if I look at this function here, like this one, what is dy du? Well, remember that I said that the derivative of u of ln of u, or natural log of u, is just going to be 1 over u. So basically it's going to be, so dy du, or hold on, yeah, dy du is going to be 1 over u. Now that means that dy dx is going to be equal to the derivative of u with respect to x, 2, times the derivative of y with respect to u, times 1 over u. Now, basically we have, so let's see, hold on. Derivative of u with respect to x, that's 2, because u equals 2x. And then the derivative of y with respect to u, that's just 1 over u. And u is 2x. So basically I'm going to say that dy dx for this one is 2 times 1 over 2x. This is going to be 2 over 2x. This cancels out. We're just going to get 1 over x. Now, that is the derivative. That is what y prime is. Okay? So looking at this, u can be equal to ln of 2x. this can be what u is. Du, it would be, so basically u equals 2x, and if we write this in y equals sine of the ln of 2x in that form, we can say that that du dx would be, so give me 1 second, hold on. If I'm a little bit rusty, guys, I'm sorry. This is very new to me. So yeah, give me 1 second. So du dx, we already said the derivative of y, which was really just the derivative of this part that we found over here when we said y equals ln of 2x, it's really just 1 over x. And so, it would be, hold on. Yeah, it would be 1 over x. So that's du dx. And then, when we said that y is equal to sine of ln of 2x, we can make, so we can say that y equals sine of u. And we know that u is equal to ln of 2x. So that means that dy du is going to be the cosine of u, right? That's what it's going to be. So then we have, dy dx is equal to dy du times du dx, okay? So then we have, this is equal to cosine, and we said it was cosine of u. However, we can substitute u back in. Well, actually, we can do it this way. Cosine of u times, and then du dx can just be 1 over x, or 1 over x. So then we go ahead and just do u substitution, right? We substitute u back in. We said that u was the natural log of 2x, right? Or wait, did we? Hold on. Yes, we did. So it's going to be cosine of ln of 2x over x, right? So yes, that's what the whole derivative of this is. That's really what that's what f prime of x is in reality. Now, the way that I would do it, and let me actually charge it. The way that I would do it here is, I would, so let's see. If I grab it again, and actually we did it. We did do it. So, never mind. So you see how up here, if you look up here at how I did it, so look at the comparison, basically. The way that I did it was a little more, I mean, it was a little shorter, but this is how I did it over here. Versus over here, we did it using, so this is Leibniz Notation, and this is just, I don't really know what to call that form, but I just kept taking the derivative from going outward in, okay? That's how I did it. Now again, you don't have to do it the way that I did it over here. You can use Leibniz notation if you're more comfortable with that. But I will admit that for me, Leibniz notation takes a little longer. But like I said in this video, I will do you know, I did want to demonstrate using both, because I don't, in reality, like, I don't think that, that's, how do I say it? Like, I don't think that it would just be fair for me to just show one and not show the other. But yes, I mean, in reality, like I said, you can do it any way you want to do it. And yeah, that's just how it works. That's how chain rule is. It's you take the derivative of the inside or the outside, leaving the inside alone, and just keep going from there. That's the easiest way I can do it. So we're gonna do one more, and then that'll be it for this video, because I don't want to make it too long. I feel like these problems take way too long. So give me 1 second. Okay, so so let's do one where, let's do this one. E to the sine of x plus x to the fourth. Okay. Now again, I'm gonna demonstrate how I do it, and then we can use Leibniz notation to do it. Okay. So basically here I say, well, f prime of x, I'm gonna put, since we know that the derivative of anything that's u of e to the u, that's just going to be e to the u. So we're going to keep the u part the same. E to the u, so it's going to be e to the sine of x plus x to the fourth. And then times the derivative of sine of x plus x to the fourth. So then we have e to the sine of x plus x to the fourth. And then times the cosine of x plus 4x cubed. Now, you can do it like this, or you can distribute the e to the sine of x in. So e to the sine of x plus x to the fourth, cosine of x plus 4x cubed e to the sine of x plus x to the fourth, like this, right? Now let's do it using Leibniz notation, okay? So we're going to copy it again. F of x equals e to the sine of x plus x to the fourth. What am I going to make u equal to? So u, in this case, we can rewrite this as y equals e to the sine of x plus x to the fourth. And then I can say, okay, sorry guys, give me 1 second. I can say u is equal to sine of x plus x to the fourth. And then I can say, okay, I can say that y is equal to e to the u. So what is du dx though? The derivative of u with respect to x. That's going to be sine of x prime plus x to the fourth prime. So du dx is really just cosine of x, the derivative of sine of x, which is cosine of x, plus 4x cubed. Okay. Now, what about dy du? That'll just be e to the u, right? And so if I put that in, I can say that dy dx is going to be equal to, and you can say so it's going to be dy du, which is e to the u, times du dx, which is cosine of x plus 4x cubed. Now, what is u? U is just sine of x plus x to the fourth, right? So in reality, dy dx can be the following. So basically, you substitute u back in. U is this part here, okay? So we're going to say e, dy dx is e to the sine of x plus x to the fourth times the cosine of x plus 4x cubed. And again, you can distribute. You can say that dy dx equals e to the sine of x plus x to the fourth cosine of x plus 4x cubed e to the sine of x plus x to the fourth. Both of these are correct. So if you look at how I did it over here, we got the exact same answer, okay? I would go over more problems, but I don't want to make this video way too long. But if anybody has any questions, please let me know. So in the next video, what I'm going to do is I am going to do a mixture of derivatives, and it's going to be, hopefully it won't be that bad, but I am going to try my best to explain it. There is one more, so actually I'll do it in the next video, because basically, yeah, I mean, this was mostly based on chain rule, and in reality, I didn't want to, how do I say it? Like, I didn't want to extend it more. So with that being said, guys, thank you so much for watching. Please like, comment, and or subscribe. And if anybody has any questions, please let me know. And I will see you guys in the next video. Bye, guys.